Okay, so we're going to prove that if A divides B and B divides A, then A is equal to B or A is equal to negative B. Okay, so let's go ahead and start this proof. All right, so we have that A divides B implies that B is equal to AK, where K is an integer, right? Okay. So we also have that B divides A. So this implies that A is equal to BQ, where Q is some integer, right? Okay. So now what I can do is I know now that B is equal to AK, but I also know that A is equal to B times Q. So I can substitute BQ where the A is. So I have B is equal to B times Q times K. And then, of course, using the associated property, I can write this B times Q times K. So what I have is I have B is equal to B times Q times K, right? So now, what this tells me, so I have B is equal to B times Q times K. So that means that Q times K must be 1, right? Does that make sense? So if B is equal to B times Q times K, that means Q times K must be 1. So there are two instances where Q times K is 1, where Q and K are integers, right? So that means, let's see, this means that Q is equal to 1 and K is equal to 1. Or we have this case, Q is equal to negative 1 and K is equal to negative 1, right? These are the two cases where Q times K would be 1, given that Q and K are integers, right? So now what we have is I know now that A is equal to B times Q, right? So I have A is equal to B times 1, right? Because A is equal to B times Q, and Q is 1, right? Or A is equal to B times negative 1, right? Make sense? Because Q is either going to be 1 or negative 1. And of course, this implies that A is equal to B, or A is equal to negative B. And that's what we wanted in our proof, right? We wanted A is equal to B or A is equal to negative B. So that's it.